Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR Hyderabad. Today I am going to explain about mathematical models. Before that previous session we learned what are the types of feedbacks and types of effects, as well as the transfer function, what are the important formulas for the transfer function. All these are learned from the previous session, and today topic is mathematical models. Let's move on to the overview of today topic. Is here just observe mathematical model and what is the use of mathematical model, and what is mean by analysis, or what is the analysis and design of mathematical model, and what are the mathematical models are available. That is differential equation model, transfer function model, and as well as one is the state space model, but that one is we learn from the 5th unit only. But here in this unit we learn differential equation model as well as the transfer function model. The state space model is one of the mathematical model is available. That one will be learned from the 5th unit. Okay, coming to the mathematical model. Here, what is mean by mathematical model? The control systems can be represented with a set of equations or set of mathematical equations as known as the mathematical model. These models are useful for analysis and as well as design of any control systems. What is the meaning of analysis and design? Now see here, just here observe what is the meaning of control system. Is represented with the mathematical equations. That is nothing but the mathematical model. These mathematical models are useful for, what is the use of mathematical model? These are used for analysis as well as the design of any control systems. Coming to the analysis, what is meaning of analysis? Analysis of a control system means finding the output when we know the input as well as the mathematical model. From that we are going to get the, or we are going to find the output. That type is nothing but that is process is nothing but the analysis of control system. And coming to the design of control system means finding the mathematical model. Just finding the mathematical model when we know the input and output. When we know the input and output, from that we are going to find the mathematical model. This process is nothing but the design of control system, and analysis is nothing but finding the output when we know the input and mathematical model. This is the analysis and design. We have some of the mathematical models are mostly used in control systems, that are differential equation model and transfer function model and the state space model. The state space model we learn from the 5th unit only, and but here differential equation model and transfer function model we are going to learn from the 1st unit. Here differential equation model, the best examples are the electrical systems, and transfer function model is the block or block diagram. These are the main examples for the differential equation and transfer function model. And coming to the differential equation model, just here observe, in differential equation model, it is a time domain mathematical model of control system. The differential equation model is nothing but it is a time domain mathematical model of control system. We are going to follow the some of these steps to design the any differential equation model. To design any differential equation model, we are going to follow these type of steps. So one is the apply basic laws. Basic laws, what are we have? Basic laws, Kirchhoff voltage law or current law or mesh law, as these all are going to follow or going to apply for the given control system. From that we are get the differential equation. Just here observe, the first step is apply the basic laws. The basic laws are KVL, KCL, means Kirchhoff voltage law or Kirchhoff current law. That laws are going to be applied to the control system. And next, The second step, get the differential equation in terms of input and output by eliminating the intermediate variables. If any intermediate variables are available, that will be is eliminated by applying the laws. Then we will get the finally differential equation. These two steps are need to follow for design of any differential equation models. Next, coming to some of the examples for the differential equation model here. One example I am going to consider here. Consider the electrical system. Just here I am going to draw the electrical system as shown in the here. Just I am going to draw. Just see here, observe the figure. I am going to apply my input signal. This is the resistor, and here the inductor, and this is the capacitor. This is my input and negative. Vi is our electrical system input and V output across the capacitor. I am going to apply the output voltage V output across the capacitor, and input voltage apply here Vi for the electrical circuit RLC. This here observe RLC, these are in the series circuits. Next, for this circuit consists of resistor and capacitor and inductor. All these, by using all these electrical elements, we are going to make a one electrical systems. Here just observe all these electrical elements RLC, resistor, inductor and capacitor. These are in the series connection. I consider here series connection of RLC, and the input is Vi and the output is V0. The input is apply this circuit Vi and the output across the capacitor is V0. These are represented here. Next, observe this circuit. From this circuit, how to design the differential equation we learned the previously already learned. Means here we just apply the any basic laws to the given control system, right? That is, we need to follow the first step. Apply the any basic law. Means here I am going to apply, or else give the mesh analysis, or else apply the KVL for the given circuit or electrical circuit. I am going to write here or apply from the mesh equation, or else apply the KVL mesh equation from the circuit is, I am going to write here, just here apply the input voltage Vi equals to mesh analysis, here mesh for Ri resistor, and here current flowing like this direction Ri, plus here inductor is there L into di by dt, plus here the voltage across the capacitor is V output. This is the one equation. And next, coming to the second equation, or else the output voltage across the capacitor, means here the current through the capacitor. I am going to consider here the current passing through the capacitor is current passing through capacitor. Just I am writing here I equals to C into dV0 by dt. This is the current passing through the capacitor. Current passing through the capacitor, we will get the I equals to C into dV0 by dt. I consider as this equation as, or else this equation directly I am writing 2, or else I equals to C into dV0, no problem. Next, here the I value substitute in this equation 1. Now I am going to substitute the I equals to C into dV0 by dt in the equation 1. From that equation I am going to get here, just observe, substitute I value in equation 1, that is V in Vi, output voltage Vi, sorry, input voltage Vi, and equals to R into I in place of C dV naught by dt plus L into d by dt into I equals to C into dV naught by dt plus finally plus V output. From that, finally we got the Vi equals to R into C dV naught by dt plus L into C, here d into dt square V naught by dt square plus V naught plus V naught. This is the equation. Next here just observe, or else here apply the Laplace transform. Apply Laplace transform to the this equation. For that I get the 1 by here, and also LC is common from this circuit, this equation. Just LC is come to the left side, and also apply the Laplace transform for the equation 2, or else I am writing the equation. Just consider as apply here just V I 1 by LC. Here we are getting Vi equals to R into C dV naught by dt plus LC into d square V naught by dt square plus V naught. This is our equation. For this, from this equation I am going to consider or take the LC from the equation common. That will be move into the left side of this equation. So this one is 1 by LC. 1 by LC into Vi equals to here R by L dV naught by dt plus here LC is common, so here d square V naught by dt only, and plus 1 by LC into V naught. This is the equation 2. I consider as equation 2, and this is the second order differential equation. This is in the form of second order differential equation, the highest order here. See, d square V naught by dt. So that's why this is the highest order is 2. So this is the second order differential equation from the electrical circuit. This is the differential equation. Next, coming to the transfer function model. Just here observe, the transfer function model is in the form of S-domain mathematical model. For differential equation model, time domain. Here transfer function model is S-domain mathematical model. Just here observe S-domain mathematical model. The transfer function model is a S-domain mathematical model of control system. The transfer function for the any LTI systems can be defined as the ratio of Laplace transform of the output to the Laplace transform of input by assuming the any initial conditions that are the zeros. Already we learned for the previous transfer function, one topic is there, from that we learn already. Here just observe, if x of t and y of t, or I consider here these two are my, x of t is my input and y of t is my output. Apply into the any LTI system, then corresponding we should apply any Laplace transform for the inputs. We will get the x of s and y of s. For applying the Laplace transform for the x of t and y of t, we will get the x of s and y of s. So here therefore we observe for any LTI system, for LTI system of the transfer function is equal to the ratio of output to the input. Just here observe, here output is y of t, means in S domain y of s, x of t is the input, in the S domain x of s. The transfer function for these two is nothing but the transfer function is equals to output by input. Means here output is the y of s and input is the x of s. Here just observe the transfer function model can be represented like this. Just here for this is I consider as one LTI system, and for the input is the x of s and output is the y of s. In this block represented with the transfer function y of s by x of s is represented with the transfer function that is inbuilt of the inside of the block. Just here observe the representation of LTI system with a block. This is a block having the transfer function inside it, that the transfer function is nothing but the output by input, that is y of s by x of s. Here x of s is the input of the given block and the y of s is the output of the given block. Here this is the transfer function model. For the best example for the transfer function model equations or transfer function model is in the form of always in S domain. Here just observe the one example. I am going to consider one example of transfer function model. Example of transfer function model. Same I am going to consider the previous example, just RLC series RLC circuit with the input is Vi and the output is the V output across the capacitor. Just I am going to consider here resistor, inductor and one capacitor. The voltage across the capacitor is V output. Pause. Just here observe. This is our RLC circuit with the input is Vi and the output across the capacitor is V output. RLC circuit and apply some voltage I of t or else I, no problem. Here the example to consider the transfer function model. So before we derive this expression, derive the equations from the using this RLC circuit, applying the input voltage is Vi and the output is V output. For this circuit we get the some differential, second order differential equation. We got that one is I am going to consider here. Just observe, this is our second order differential equation. 1 by LC Vi equals to R by L. This one just I am going to consider here from the equation 2. From the equation 2, just write the equation 1 by LC into equals to d square V naught by dt square plus R by L into dV naught by dt plus V output 1 by LC. This is our second equation. This is our second order differential equation. I am going to apply the Laplace transform for the given second order differential equation. Now here just apply Laplace transform to the equation 2, By applying the Laplace transform, we will get here 1 by LC or 1 by LC into V I of S Vi of A is equals to, in the form of S domain, transfer function model is always in the form of S domain. Write it 1 by L into Vi of A is equals to d square by dt square, the second order. So second order differential equation means S square. S square into V naught of S plus R by L into d by dt S into V naught of S plus V naught of S into 1 by LC. 1 by LC. From this, just here observe the next step. Just here I am going to write S square, this S square V naught of S plus R by L into S, V naught into S plus V naught S into 1 by LC. Now I am going to write this one first. S square into V naught of S, S square into V naught of S plus R by L into S plus 1 by LC into V naught of S equals to 1 by LC into Vi of S. What is the meaning of transfer function? The Laplace transform of output to the Laplace transform of input, right? So the ratio of Laplace transform of output to input. Here, what is the output for this electrical circuit? V naught. The input is Vi. So for this, here just V naught is common from all this. R by S into here, R by L into S into V naught of S is there. I am going to common the V naught of S from this. S square plus R by L into S plus 1 by LC equals to 1 by LC into Vi of S. The transfer function is equals to output by input, means V naught or V out of S by V in of S equals to, just this one, this term is moving to the right side. Next I am going to write just 1 by LC, this is there already, divided by, this term is complete into the denominator here, S square plus R by L into S plus 1 by LC equals to transfer function. Already I am writing here. This one is the transfer function of the given electrical circuit. Just here observe, this is nothing but transfer function of second order electrical system. The transfer function model of this system is representing with, I consider here Vi of S is our input. I am going to consider one block. In this block, 1 by LC divided by S square plus R by L into S plus 1 by LC. Output is V naught of S. Here, this is the second order electrical system transfer function model. The block having the transfer function inside it with the input is Vi of S and output is V naught of S. This block is consists as the transfer function of the electrical system, that is 1 by LC divided by S square plus R by L into S plus 1 by LC. The input is Vi of S and output is V naught of S. This is the transfer function model. What we learn for the today session, what is mean by mathematical model, and what are just I'm going to conclude all these today lesson topics. Just what is mean by mathematical model, what are the use of mathematical model and analysis, all these analysis, design and transfer function, differential equation model, all this we learn. The state space model we learn from the 5th unit, and here today's session we learn the what is the use of mathematical model, what is mean by analysis, design, differential equation model and transfer function model, and with the examples. This is about the today session mathematical models. I hope you understood each and point. Thank you all.